Hey folks, Mark Brown, Azure Cosmos DB TV. We're back, and this week I've got old friend of the show, Theo van Kraay. How you doing, Theo?
I'm doing great. How are you doing, Mark?
I'm doing pretty good. Early morning here in US, and enjoying we're back to normal Seattle weather. I guess it's just raining, which is better than like rain and snow and rain and ice. Sheets and sheets of ice, but just rain. So I'm
Yeah, well,
happy. It's no
it's
longer dangerous or death-defying to go to work in the
yeah,
morning. So,
yeah. Well, it's freezing over here, so
well, it is
I'm,
winter. I guess you get a little
as
bit
you
of
can see, I'm wrapped up here.
yeah. That's well, yeah. I'm looking forward to July personally.
Yeah.
So, hey, we haven't had you on the show in some time, and love getting you on because we have quite an extensive array of SDKs and tools and everything for the Java ecosystem. And we wanted to get you back, talk about all the latest and greatest updates we've got for our Java SDK and for Spark and for Spring. And I don't know if I've missed anything, but all of that greatness that we've got, the Java ecosystem, the Java community is really important to us. We put a ton of work and engineering into making a great developer experience for our friends in the Java ecosystem. So wanted to bring you back and tell us kind of all the latest and greatest what's going on with it.
Yeah, so I've got a bunch of slides here, and I tried to pack an absolute ton of information into a small number of slides. So we'll see where we get. But I wanted to give a kind of an overview of everything, really, that we're doing, which of course is not really possible. But I've got a fair amount of stuff here to cover. So a little kind of agenda, I guess, stuff that I'm going to walk through, a recap of Cosmos, just in case there's anybody who's dropping in, watching this video and has never heard of Cosmos DB before. A little recap on exactly what we're talking about here. And then I'll do an overview of what we call the JVM ecosystem for Cosmos DB, some best practices on Java SDK, which is the core project that we work on, and then the same thing for Spring Data, and I'll talk about the Spark and the Kafka connectors as well.
Awesome.
Yeah. So recap on Cosmos DB, in case anybody doesn't know, this is one of my favorite images that I've seen on any of the presentations that we do, what the typical activity of an app looks like. Of course, in the modern day, most apps are going to be touching people around the planet, right? So you're going to have activity all over the place. And of course, I mean, this is, friends of the show will know exactly what Cosmos DB is all about. It's a cloud native database service. It's built with multi-tenancy from the ground up, resource governance, and exploiting, you might say, all of the cloud core properties and economies of scale that you get out of the cloud. And of course, this isn't possible on traditional databases, and it is fully managed and secure. And the proof of the pudding, of course, is all of the SLAs that we have, which to date, I don't know of any other database service that matches Cosmos DB for this level of comprehensive SLAs on throughput, latency, availability, and consistency, and so on. And of course, there are a bunch of apps that run on Cosmos DB, and these are just the internal ones. A few little tiny apps here. Of course, these are monster services that depend on Cosmos DB. And of course, there are also external customers, I should say. And believe it or not, some of the biggest, in fact, the biggest customers that we have, the biggest external customers that we have, run Java applications connecting to Cosmos DB. So as a result, all of our Java client libraries are pretty battle tested at this point. And so it's definitely worth talking about what that ecosystem looks like. So I guess a really whistle-stop tour of the ecosystem. But first, I wanted to just call to attention, I guess, what does Java look like on Azure these days? If I joined Microsoft maybe a little bit over 6 years ago now, I remember at the time when I mentioned Java to people, there was kind of raised eyebrows and sort of nervous looks and kind of, let's just change the subject to .NET or something at that time. But of course, it's completely different now. Java is massively used very widely, even just internally at Microsoft, well over 2 million JVMs at this point in production. All of those internal customers there are using Java, and the commitment to the Java ecosystem right across the whole of Microsoft is massive. The most notable of these is the fact that Microsoft has entered the market as a JDK provider, believe it or not. So we have a central Java engineering team that produces its own version of a JDK and gives full support from top to bottom in that respect. So, and if that wasn't enough, we also have Azure Spring Apps, which is a fully managed PaaS service for running Spring apps, and it's supported by Microsoft and VMware, who of course own Pivotal, who were the custodians, are still the custodians of the Spring ecosystem, which is the most used abstraction framework in Java.
It's very popular, isn't it?
Yeah, it's massive. I wonder if it's the most popular software abstraction anywhere, regardless of Java, regardless of programming language. I just seem to see it all over the place. It's really not surprising in one sense that Microsoft is committed to this heavily with a fully managed offering on this.
Yeah.
So yeah, I guess onto the ecosystem then for Cosmos DB. I always feel, when I've showed these slides before, I always feel like what we really have is quite a small piece of the Java picture in Azure, because the commitment and the investment is so big in Microsoft these days. But our investment is big too, relatively speaking, on Cosmos DB. Ostensibly, we're talking about any framework that's Java based that could be used to connect to Cosmos DB. But more practically speaking, there are 4 projects that we maintain: the Spark connector, Spring Data Client Library, the Kafka source and sync connectors, and of course the core SDK on which the other 3 have a dependency on. And so I'll just start by touching some best practices of Java SDK. By the way, all of this stuff that I'm talking about, you could find in various places, in samples and in documentation. But I guess sometimes it's good to hear somebody talk about it, some visuals, and that helps trigger learning. And then, of course, I'm sure, Mark, you'll be sharing links here and there.
Lots of links. I've got one up right now for our Java best practices. So yeah, absolutely. As you go and talk along, I will provide links for folks to go and follow along for themselves.
Yeah, awesome. So I'll go an overview of the SDK and what we mean by sync versus async, connection management, performance tuning, diagnostics, client metrics, and some new high availability features that we introduced recently. So I guess, first of all, what is the Java SDK? What is it made from? So it's designed for reactive programming. It uses Project Reactor, which is an open source framework in Java. It's a declarative programming flow as opposed to the more imperative style that most developers will be used to. And so you have this is a bit of pseudocode here, this kind of chaining of events, and it's described as a stream of events of data passing through a pipeline of operations. And you describe the high-level execution, and then the language implementation, in this case, Java, or Reactor, I should say, decides when and how to implement operations in terms of back pressure and multi-threaded asynchronous operations. So multi-threading and asynchronous processing is really totally baked in to this model. The async API, as we call it in the Cosmos Java SDK, it just sends requests to Cosmos DB, uses Reactor Netty with async IO at the OS level. So there's no block waiting for responses. You have to explicitly block, otherwise everything is asynchronous. and it just pushes out as many requests as your hardware can handle. We also have included a sync API, as we call it in the Java SDK. And the reason we included this is, as I said, it's kind of the more familiar programming style, kind of if, then read into variable, and sort of step by step, line by line, as it were. But if we compare sort of what async and sync looks like when you're declaring the initial objects, it looks fairly similar. And even when you're building a Cosmos client for connecting to Cosmos DB using Cosmos Client Builder, again, fairly similar. But as soon as you start getting into operations, you start seeing the difference with things like mono and flux on the async side that you have to start becoming familiar with if that's not already familiar to you as a Java developer. So again, just a kind of simple example here. In the sync API, this is kind of contrived. You wouldn't really have void on a read items method, but it's just taken from a sample. It's fairly sort of synchronous. You can and serial processing. You've just got a for each, and it's going to loop through call to read item and do each of those serially and process the response serially as well. But when you're doing this in the async API, straight away you've got this flux object that can take or represents n number of async sequence values. And then when you're handling those objects, each one is going to be represented by a mono, which is one publisher. And then you will process the responses. Again, all of these requests are being done in parallel. You don't need to explicitly code that. That's just the way it works. And then when you're calling methods like flatmap to get the responses, they will be done in parallel as well. So you can see it's all async from the ground up. And then to close off the call to that method, you're either going to call block class, so you're going to block on all of these asynchronous things happening in parallel, or you can subscribe, in which case you can do other stuff asynchronously also. So it's, as I said, it's pretty much asynchronous and multi-threaded from the ground up. So then question emerges, if you're used to the more imperative style, which should I use? What is the advantage of using async? After all, if I'm using sync, then can't I just hand crank my own sort of multi-threading if I want to? Well, async is obviously faster and easier for async programming. It's designed that way from the ground up. It can be a bit more verbose and harder to understand if you're first getting to grips, or you're getting to grips with Reactor, let's say, and that sort of Lambda style syntax, if you like, for the first time. If you really have no async processing required in the app, then maybe arguably sync is easier to maintain. It's less verbose, maybe more intuitive to read for the typical Java developer. But to be honest, for the vast majority of use cases, we really recommend async. And in the end, sync is just a wrapper over async with blocking calls. That's all it is. So if you were thinking about just using what you're familiar with and then just hand cranking, multi-threading when you need it, that's really quite redundant. It's not a disaster if you do that, but we really recommend getting into async and understanding how that works.
Is there really a reason to use sync anymore? I mean, I think the guidance that I've given and been given myself is, hey, if you're writing applications that are talking over a WAN or any network, you should really not be doing synchronous calls. You should be doing things async, especially over kind of a wide area network, it seems, or even in a distributed environment. Is that kind of your take on things as well, or?
It's a good question. The only reason I can think of is comfort and also ease of maintenance. If you're building an app that is literally only going to be sync calls the whole way through, maybe it's easier to maintain. Maybe it's just easier to interpret for the average developer. But to be honest, that's the only reason I can think of. You know, the not being used to the syntax is probably not a good enough excuse for literally any other use cases. There's any async processing that needs to happen, yeah, we strongly recommend async. But if you're using GitHub Copilot, of course, as with most other things, this makes it a lot easier, especially with the syntax of Reactor. It can be kind of a bit opaque at times. If you need help with that, GitHub Copilot is really effective here. At least I've found it to be so.
So I got a question for you. I've messed around with the GitHub Copilot with our other SDKs, and even just on conceptual stuff, and it's very, very good. Are you finding that with all of our Java ecosystem stuff?
Yeah, it does. It especially is good as you might imagine it interpreting the Reactor syntax, which is kind of independent of SDK. But even with all of our SDK stuff, there's plenty of data in the training of the codex to anticipate what you want to do. So, I mean, you just saw there, all I had was read items returning a type of flux family, and it pretty much just gave me exactly what I wanted. So,
yeah,
in most cases, it will do that. Of course, there are gaps, but where it's really useful is where there's some difficult syntax that you need to get, manipulate an object or return a particular type from an object where it's not obvious how you get that type, if that makes sense. It does that really well. So, yeah. And that's useful if you're getting into something like async and Reactor, because if you're coming from the more imperative style, you're going to struggle with that. So, yeah, definitely a great tip.
Yeah, I'm glad to see that in the Java stuff. I think it's quite remarkable.
Yeah.
You could build like a whole data access layer against your data stored in Cosmos rather easily using GitHub Copilot in an editor. It's pretty fantastic. So,
I'd say I've gotten to the point where I couldn't do without it now. So it's kind of scary if it stops working one day. But
yeah, I'm with you actually.
Yeah,
it's making me even lazier as a developer. So,
yeah. Anyway, never mind. Okay. So a few connection management best practices here. So I'll talk about some basic tips, direct versus gateway, and a few advanced tips as well. This is by no means everything, but I think these are the kind of 101 basics that everyone should know. First one, most obvious, of course, install the most recent SDK. Latest major version is V4. That's been around for quite a few years now. And what we do periodically every 2 or 3 months is we release a version that we strongly recommend to customers to take. And that's not to say that older versions are broken, but usually when we do that, it's because we found some major enhancement or some major problem with some particular feature that we want to fix. If you're not using that feature, obviously that won't affect you. But I would recommend monitoring this regularly and whenever possible, taking the minimum version that we recommend. Like I just said, use async API to max out provision throughput. It's far more efficient for async and multi-threaded parallel processing and so on. Because, as we'll see later, the SDK is a fairly, let's say, thick client, fairly resource heavy. We definitely recommend configuring an async logger and disabling NetEase logging to avoid any additional CPU overhead here. And so getting into gateway versus direct. So gateway mode, Cosmos DB has a gateway, and this is responsible for routing requests to the partition and associated replicas at the back end. So the advantage, of course, is that you only have one connection from your client. So if, let's say, you have 3 partitions, there's only one endpoint, one port that you need to open up for firewall reasons, and then the max connection pool size is more than enough in that case. The trade-off, however, is, of course, there's a gateway in between. So if you're really concerned about getting the lowest latency possible, and indeed, if you want to be under the umbrella of our latency SLA, you really need to use direct mode. And direct mode, which is unique to the Java and .NET SDK, the SDK will connect directly to partitions and replicas. So the advantage, obviously, is low latency, but the trade-off is, of course, if you had only 3 partitions, there would be 12 endpoints. And because the SDK maintains 130 connections by default per endpoint, this means you're going to have around 1,560 or up to 1,560 connections, depending on how many active threads you have ongoing in the application. That's just for 3 partitions. So it's fairly high overhead, but there's trade-offs everywhere in software. In return for the high overhead, you get very low latency, and it improves availability to some degree as well. Few tips if you are using direct mode. Again, they're kind of 101, but they do trip up some customers. If you're on a Linux system, the number of open files needs to be thought about. You need to have enough open for your configured connection pool size, and of course the number of connections you have in Cosmos DB is maybe more than the average application, so you'd need to make sure that you have enough open files configured. Idle endpoint timeout, the default is 1 hour. The important thing here is that the SDK is opening connections and keeping them open. There's a little bit of overhead for opening a connection initially, up to sort of half a second. And this can cause tail latency if you have sort of sporadic workloads and the SDK needs to keep reopening connections every time there's been a period of dormancy, and then you've got some traffic coming through. So recommend keeping an eye on that. Max connections per endpoint. I personally would not recommend changing this. You can thread the needle. So if you're sort of trying to balance between the cost of high resources on the client to maintain all these connections versus the low latency of having the connections open, then you could try and balance somewhere in between. But really, the default sort of hits the sweet spot for most applications in terms of elasticity. So if you're starting small and then you need to scale out quickly, that usually is a good number of max connections to have. For gateway mode, the only thing to be really concerned about is max connection pool size and idle connection timeout. And the defaults are fine for gateway in this case. So client resource is another very important thing. We strongly recommend enabling accelerated networking. Of course, this is also something that's stipulated in our latency SLA. We recommend at least 4 cores and 8 GB of memory for the machine that the client is running on. That might seem quite a lot, but of course, if you have hundreds of partitions, you maybe have many thousands of connections. Maintaining those connections could be quite expensive. What I would say is, although it seems like a lot, you shouldn't need to scale out very often or scale up very often. The overhead is really to maintain those connections. Once they are established, it's not like it will be a while before you would need to get to the point where the actual traffic and the processing that's going on the SDK would cause you to need to scale out. So it's really just the headroom for all of the connection management and the associated tasks with things like cross-partition query and so on that need all of that memory and processing. But beyond that, you don't really, it's rare that you would need to scale out once you've got the sort of, let's say, the basic requirements in place. And then the last thing, I think this sometimes skips customers by. They know that singleton is a general pattern that's good to sort of minimize resources, but it's really important in Cosmos DB with the SDK because, as I said, the Cosmos client is fairly heavy in terms of overhead, in terms of the number of connections it's maintaining. You really don't want to be creating new Cosmos clients every time you're doing something, or even more than once, really, within the scope of a JVM, let's say. So really make sure you're using the singleton pattern wherever possible, unless it's absolutely unavoidable, I would say.
Yep. By the way, I had just another quick note on kind of well, you're going to talk more about performance tuning. So I'll let you go through this.
Yeah. Okay. Yeah, so I mean, performance tuning, actually a lot of these tips, to be honest, are generic tips in Cosmos DB, but they're just worth mentioning in the context of SDK. Of course, use point reads. There's a blog about point reads. It's referring to .NET, but the principle is exactly the same. Of course, point reads are different from queries and much more efficient. Opt out of indexing attributes that are not used in the query predicates. Again, it's fairly obvious, but maybe not so obvious to people who don't use Cosmos DB. For those who don't know, Cosmos DB indexes everything by default, so it's more of opt out rather than opt in terms of indexing. And the more indexes you have, of course, the higher the cost of writes. So you want to opt out where possible. Minimize cross-partition key queries. This tip really is specific to the Java and the .NET SDK, which has the same feature, which is if you need to do many point reads, or in other words, if you need to get a lot of documents back quickly, I mean, really quickly, quicker than a query could get them back, for example, but you don't want to have thousands of client machines doing this in some kind of complicated scatter-gather pattern that's going to cost you a lot. Read many APIs is kind of a good convenience method that helps you navigate the trade-off between these two. So there's another tip there. And generally speaking, I definitely would recommend checking out all of the cost optimization stuff that we've published. Would be helpful for you regardless of whatever SDK you're using. And then lastly, on this little section here, for handling high throughput scenarios, I would say, again, this is not really specific to SDK, but I would say use the lowest consistency level required. It seems obvious, but we see certainly among Java users, I don't know if this is more so for Java users or not, but we see a lot of workloads that are, let's say, heterogeneous, so that there are different types of workloads that have different consistency requirements in the same account. And that's fine. You can do that. Of course, Cosmos DB allows you to override the consistency setting at a per request level. But when that's happening, you're still paying the performance cost on the write path, right? If you set strong consistency or bounded staleness, even if you override the setting at on the request side, on the read side, when the write happens to the database is still guaranteeing, local quorum or strong consistency across replicas and so on. So I would recommend thinking about how the workloads look and where relevant, separating them out into different accounts if necessary.
Yeah, I don't know if people realize this, by the way, but if you use strong consistency or even bounded staleness, your reads are 2x the cost of session or less, right? So
yeah.
So that's nice. You get, at least for a strong consistency, you get an RPO 0, but that's an insane amount of overhead or cost on your reads if you don't need it.
Yeah.
Right. And not everything needs strong consistency on there. The other thing too is you can't override the writes. Consistency is a read path thing, right? So you can, if you don't, so when you do relax it, right, you can do it on a read basis, which can make sense. Like if you're having like an IoT scenario and you have an RPO 0, okay, great. You're forced into using strong consistency. But if you have like a dashboard or something that's trying to keep track of stuff, you could use like a weaker level of consistency. You probably don't need strong reads for something like a dashboard, right? It could be eventually consistent, right? As long as it gets there. So anyway.
Yeah. I mean, I get it. I know why it happens. And usually customers started down the road of one particular consistency model, and then they just have a bunch of different workloads, and they didn't want to move it into a different account. So they just, tried to, so it happens, but I would recommend a little bit more diligence in this kind of with this, specifically with consistency and how your workload looks in that case. Of course, pretty obvious, co-locate the client in the same Azure region. Retry logic. The SDK does have built-in logic to handle all manner of different failures. We don't retry writes that fail with transient errors in the Java SDK by default, as we don't know if they're idempotent or not. But you can configure retryable writes. This is a very recent feature in the SDK. For 429, so this is rate limiting when you've exceeded request units. This is pretty much the only type of error that's configurable, and of course you can configure the number of retries that you're going to attempt, or the retry wait time, or both. But for every other error, there is a retry policy that's non-configurable. If you want to, we have documented under the repo for the Java SDK, the logic and control flow of how that retry logic works for all of these errors. And we've also done this in text format. So we've gone through the logic for the write path and the read path, depending on the consistency type and so on. If you really want to get into that, personally, the whole intention is that this is meant to be transparent, so you shouldn't really need to review this. But if if you're curious about the behavior of one particular error, this is all documented if necessary.
Yeah, if you want to know, we've got it there for you. So that's I'm glad you guys documented that.
Yeah, for errors and exceptions, again, it's a kind of simple 101 basic tip, but surprising for how many customers this goes by. I would capture Cosmos diagnostics from day one. For exceptions, in every case, capture the diagnostics. And then for normal operations, I would focus on latency. So if the request takes longer than you expected, and obviously you're going to put a timer on there or something, then capture the diagnostics when it exceeds that threshold. The reason I say that is the diagnostics, there is an overhead on the serialization of the diagnostic string, which you'll see in a minute. But you shouldn't, obviously, though, you wouldn't really need it for anything more than exceptions and requests that are taking longer than anticipated. So kind of that segues me to diagnostics. Again, I'm only really touching this at the high level. Troubleshooting and new micrometer metrics that we've added to Java SDK, which is a pretty cool feature. So the diagnostic property, that's been around for some time. And it's a response object. It contains things like CPU and memory levels on the compute host for the SDK instance that's running, and a whole bunch of server-side metrics that covers pretty much everything about the execution of your requests. So this is just a little short a clip of a demo where you're just debugging through and seeing the diagnostics string, what it looks like. And I mean, it does have a ton of information. To be honest, this was primarily designed for our support teams to interrogate and to look at and to be able to isolate various things. But there's useful information for the user to capture as well. And as you can see there, it's an opaque JSON string. It's not something that you should take a dependency on. It doesn't have a schema, and it's large parts of it are produced by the back end, but it is there, and I would definitely capture it in case you need to raise a support case if the problem that you're facing isn't obvious.
We had Justine on the other week, and that same topic came up. Like, hey, why don't we make that into like a proper JSON object? And and the reason it's clear is like, hey, this is really not meant for like public consumption. It's really meant for the support engineers, and frankly, we need to be able to change that whenever we want and do other stuff to it. That said, there is some interesting information contained within that thing, and you will be asked for it if you're having something that's kind of related or client app related. So.
And my guess is probably Justine's answer to that, or I don't know. But anyway, my answer would be that's true, but we have different ways of getting metrics that are more structured for the things that customers would be interested in. The thing about the diagnostic string is it's kind of a mishmash of things that customers would be interested in, and also stuff that's opaque and not really meaningful from their point of view. So what we have instead are things like micrometer metrics and tracing and so on. And we've released micrometer metrics for the Java SDK. So micrometer is a really popular framework that is kind of standardized and allows you to grab metrics from wherever you're getting them from and put them into tools like Prometheus and other open source metric systems and visualize them however you want. This is a little demo here, one of the samples where you can just instrument Prometheus, scrape the data from Prometheus from the client side, and then visualize it on Grafana. And again, pretty much we have all of the, or most of the useful information that you would get out of diagnostics in client metrics, and you can visualize it in a much more easy to understand way. So lastly, on Java SDK, I wanted to touch on some fairly new features that we've added in the Java SDK. And this is actually pretty unique to the Java SDK right now. It is going to be ported eventually to .NET. So what we have is, first of all, proactive connection management. So the default behavior also in the .NET SDK is that we'll warm up connections and caches for containers, those connections I was talking about before, whether it's via for direct mode for the local region, obviously, because you will be pinned to the SDK will be pinned to one region depending on preferred regions, and then fail over to other regions if the local region isn't available. But what we've added is the ability to also warm up connections to a remote region as well. So you can set proactive connection regions with a number, and then using that number, it will iterate through the preferred regions that you specified, and also open connections for those preferred regions as well. So the benefit of this is, in a scenario where there's an outage in the local region, if you have a lot of open connections and you have a lot of partitions, let's say, and you want to avoid tail latency in that scenario, because like I said, there's an overhead to opening connections. If your connection's already warmed up, then you straight away are going to fail over to the secondary region. This reduces tail latency.
So this is interesting. Also, I guess if you're, this would also reduce the latency for your first request too, when instantiating a new client. Is that true as well?
Yes, it would. The default behavior in the SDK does that already. So
oh, it does. Okay, yeah, that's interesting. In the .NET SDK, that does not happen. You basically everything is late bound with respect to the connections. So they just set up the proxies, and then you actually have to make a data plane call into a replica for something to actually happen, for the connections to actually get created. And
yeah, you're right. Yes, that's also a difference here. The main difference I was thinking about was the remote regions, but you're right. Yeah, there's a difference between the Java SDK and .NET as well.
So there you go. I had a question on Twitter 2 weeks ago. I was like, "Hey man, I'm trying to benchmark this thing, and first request sucks." And I'm like, "Just don't measure the first request." I think Matthias on our SDK team was saying that, like, don't measure it. But I guess if that mattered, then I guess they could go to Java SDK and and do away with it. So there you go, folks. Use Java.
Yeah, I'm sure there's lots of .NET developers.
Users that want to hear that. Yeah.
Yeah. So okay. Yeah. So taking that a step further, then what you can build on from that is an availability strategy. So we just talked about warming up connections to remote regions. What if you don't want to only minimize the latency or the tail latency in an outage event, or in if the local replica is slow or not available? What if you actually want to eliminate it completely? Let's say your local replica is slow, and you want to set a threshold and say, if my request reaches a certain amount, I want to speculatively send requests to another region and see if that one comes back faster than my initial request. And that's what the threshold-based availability strategy is about. So if you assume that we have East US, East US 2, and West US, and assume that we're at time T1 and a request is made to East US, you can see I set a threshold there of 500 milliseconds. If there's no response in 500 milliseconds, a parallel request will go to East US 2. If there's no response after 600 milliseconds, a request is made to West US 2. In the meantime, if East US 2 responds first, it will take that. If it doesn't and West US responds first, it will take that. So for those of you watching who are familiar with Cassandra, this is basically or very similar to the speculative execution feature that's available in the client drivers there. And this is a way of completely eliminating, well, maybe it's too excessive to say it would eliminate it, vastly reducing tail latency in these scenarios where the local region is temporarily slower than you would expect. Of course, there's a trade-off and there's also a trade-off with proactive connection management. Of course, if you're going to open up multiple other connections to the remote region as well, of course, that means a load more connections on your client side. So that's more resource that your client has to manage. And in this case, for availability strategy, of course, each request to the remote region that you do in parallel, in addition to your initial request, is not only going to consume client resource, but also RUs as well. So there's a trade-off like there is everywhere. If tail latency is really important to you, you want to absolutely minimize it. And then, of course, this is a no-brainer. But if you are more cost-conscious, then maybe you want to tolerate the tail latency and not spend too many RUs. Of course, the RUs are only incurred when you breach the threshold. And the idea is you set the threshold at a level which is sort of around, let's say, P99 or something like that. So should be, in theory, once in a blue moon or very rare that you have to do these parallel requests. But still, it's going to be extra costs. So it's something to bear in mind. And the last one was end-to-end timeout policy. This only has a negligible effect on availability, but I mention it because the existing or the previous timeout policy we had, you basically had a window of minimum 5 seconds and maximum 10 seconds. And if you wanted to cancel the request, you'd have to use the timeout API in Netty to override or sort of time out the request, but that wouldn't actually cancel the request. You still have requests running in the background, and of course this can impact availability as well. Now we have a much more seamless, much more sort of intuitive, sensible end-to-end timeout policy that you can set and recovers even cross partition queries and so on. Not really an availability thing, but I just want to throw in there that we have IntelliJ support for Cosmos DB. We've had this for a few months now. There's a tool called Azure Toolkit for IntelliJ that's pretty easy to find and install. And once you're there, if you're the sort of person that like me that likes doing everything inside the IDE and doesn't want to jump around between the portal and different things like that, it's pretty cool because you can just import documents into Cosmos DB from there and edit them in place inside your IDE while working on your whatever code that you're writing. So personally, I found that useful. Others' mileage may differ.
So I think a little mini portal in the IDE or data explorer in the IDE. Is that what that is?
Yeah, it's like a window to Cosmos DB, but then when you open docs inside the container, it's as though you're editing files in the IDE, if that makes sense. So you just edit the file, save it, and then it just saves to Cosmos DB.
Oh, well, that's fascinating.
Yeah.
Okay.
Again, not everyone's cup of tea, but it's definitely my cup of tea. So
yeah.
So best practices for Spring, which of course is another library that depends on the Java SDK, and the Spring ecosystem is massive, as we were saying before. Spring Data Framework itself is an abstraction that's focused on the data layer, obviously, and that's why we have focused on that. And I've shown this little clip before, but it's the cool thing about Spring is that it really decouples you from the database protocol, if you like. So in this case, I'm just writing a method and I'm just kind of writing out what I want to do. So I'm saying find by ID and last name. Behind the scenes, it's going to use the client library to convert that into the type of query that we want in Cosmos DB. But on the front end, this will look the same regardless of what the database is that you're using at the back end. So one of the reasons, not the only reason, but one of the reasons that people use Spring Data is they just want their code to look the same regardless of what database they're using. They don't want to have to keep refactoring things. And in some cases, they want to do cross-cloud or multi-cloud deployments as well. And they want to have the abstraction layer at that level rather than at the database protocol level, which makes sense to me. So that's kind of a little advert, if you like, of what Spring Data is all about. In terms of best practices, yeah, it's kind of pretty much the same as SDK, but of course it's going to look different. There are some trade-offs when you're using a framework like Spring. first question I guess you want to ask yourself is, why are you using Spring Data? The popular obvious reasons would be, yeah, of course, it makes app development easier by reducing boilerplate, and like I just alluded to, potentially it makes the app code more portable across different databases, and that's certainly something that we see certain companies try to do. But there are, like with everything in software, there's trade-offs. You have a loss of control, in some cases loss of functionality, in some cases because abstracting means getting rid of complexity, and sometimes you need that complexity, and of course compatibility as well. So how does this play out in Spring Data? For example, point reads. So this is the one of the basic, most often used methods in Spring Data, find by ID. This will look the same regardless of what repository it is, whether it's MongoDB or CouchDB or SQL Server or whatever. You just use the same method. But intrinsically, Spring Data doesn't have any real understanding of things like sharding and partitioning. So what we've done is optimize this so that this will be a point read if the container happens to be partitioned by ID. But if it's not partitioned by ID, we've got no way of knowing what it's well, we can know what it's partitioned by, but if you haven't provided the partition key, we can't actually do a point read. So you would need to call the overloaded method. But then the trade-off there is this method doesn't exist in the Spring Data API, so it wouldn't be understood by other databases. And if your goal is to make some code that is completely portable, then obviously this wouldn't work.
Yep.
So app config, yeah, I mean you can change from direct mode to gateway mode. By default, it's direct mode, and then again, this is maybe one of the other things. Things like this are maybe not, the configurations are maybe not quite so visible. Of course, we document them. Definitely would recommend checking out the links and samples to see how to do these various different things. But one thing I'll point out is if you're choosing downloading the Spring Data client library, it's maybe a little bit more complicated by needing to know what version of Spring Boot you're already running. If you're already running a version of Spring Boot, if say you've built an app or maybe you have a framework into which you're adding a Cosmos DB component, of course, it needs to be the Spring Data client library needs to be compatible with the version of Spring Boot that you're running. So we have a table to find this out. And of course, just like with the Spring Data, with the Java SDK, we have certain minimum versions that we recommend to get customers to take in order to get the latest and greatest enhancements and fixes and so on. So, of course, like with the Java SDK, there's a sync version and there's an async version, and unsurprisingly, async is more verbose, but it's more performant and efficient when it comes to async processing. Of course, we recommend using async. A little trick question here. If we remember what we said about point reads, what do we think happens here if we're passing in a list of user IDs in the find all by ID method? Well, you might think that read many API is used, but actually at this point in time, it's a trick question. It's not yet implemented in the Spring Data library. So again, that's one of those compatibility things. We have to make judicious decisions about what to implement and what not to implement. In some cases, it doesn't make sense. In some cases, it does. In this case, maybe it makes sense, but you could actually just implement this yourself by doing a custom query in the user repository, and then you can just add the SQL query code to do that, and it's pretty straightforward.
Got it. I thought it was going to automatically make a query, but you're saying that's going to throw an exception, is what you're saying. So.
Yeah, okay. Exactly. Yeah. And then for things like change feed, I haven't really mentioned change feed so far. Yeah, you would need to sort of hand crank that and then auto wire the dependencies and then add that as a service that you can then call from your controller code in the Spring environment. So like with any framework, there's always you always have to have a backdoor to drop down into code that isn't supported directly in the library. And then the last kind of big gotcha, maybe this is the biggest thing that we see customers slip up on. And to be fair, it's also a problem generally in Cosmos DB when running big queries that are cross-partition key queries without providing the right filters or the right partition keys. This can quickly sort of get into a very bad performance. And of course, this is less, let's say, intuitive or less or more opaque in the Spring Data Framework because of the nature of the API. The way that the API is presented, it's kind of abstracted and generic, so it's supposed to be able to work with any database, but it means things like this are more hidden, so you have to more actively think about them. As opposed to, you know, it being sort of suggested by different APIs that you're interacting with in the lower level Java SDK. So here's an example. You have the find all method that's going to do a big cross-partition query. What you really want to do is use continuation tokens, but to do that, because that's not understood as a concept by Spring Data, you have to be using the Cosmos template, which is the underlying implementation underneath the API. And again, if you have the goal of making your code portable, then that breaks that idea.
So that is a question. Is Spring used more or less often than, say, just our regular Java SDK?
It is at this point, in terms of volume and growth, it's probably the second biggest of the projects that we have, and it's the fastest growing as well. So I think in terms of the projects that are used that we maintain, the Java SDK, and in terms of volumes, actually Spark is higher volume,
Really?
just raw volumes, not in terms of the number of customers using it. But Spring is the fastest growing, and that's not surprising because so many people use Spring in the community.
Do they tend to stay there? I find Java customers tend to be, at least for us, and this is just my observation, and you would have a better, clearer view, but they tend to be more performance oriented, I guess. So do they stay on Spring Data because there are, like you're pointing out here, like for portability, great. Although I don't know why you would do that. Like people don't tend to write apps to make them super portable. Like if you're writing an app so that you can in the future migrate to another database, you maybe should rethink whether or not you're picking the right database, I guess, rather than doing that. But if you really care and you want it to stick, then obviously you want to get the best performance you can. So why I guess the question is, if they start with Spring, do they stay there, or do they go over to use our regular Java SDK and then take advantage of all the performance tuning and other stuff? Like you can really go deep, and we've had Suba from the Walmart team on here, who has done some really deep dives into, like, man, you could tweak the transport layer on this thing and really kind of squeak like nanoseconds of performance out. But you can't do any of that stuff with the Spring Data. So just curious, like what happens?
Yeah, that's a really good question. I would like to look into the retention of Spring versus the retention of SDK. I don't know the answer. My guess is they do stick around because the type of person that is building stuff on Spring Data has already accepted the trade-off, right? They've said, right, I know that I'm not going to get all of the latest and greatest or best in terms of performance or configuration or tuning, but I am going to get a framework that I can make portable, and I can also, speed to market is faster, right? I can knock things up. So they kind of bought into that. And also, maybe it's true to say, well, definitely it's true to say the type of developer that's building apps on Spring Data probably isn't thinking about building low-level software. They're more thinking about building applications, maybe. So they're not necessarily their concern is just configuring things as fast as they can. So that would be my guess, but I don't know if that really plays out. It makes sense given the nature of the framework, but then we have a lot of ISVs using Spring, and I think they but again, that's the trade-off, right? That's always the trade-off with any abstraction. It makes things simpler, but you lose some tunability, some configuration, some complexity, which maybe you need. So my guess is it's kind of about the same, because it's a totally different motivation that they have for using Spring versus SDK.
Fair point, right? Like maybe at the end of the day, it comes down to the person rather than kind of anything else. What they use and where they stick. So yeah.
I mean, the real thing I would still want to say to Spring users is, even though that's the case, and I totally understand the choosing that trade-off, still look at those basics. Still look at things like cross-partition query, point read. Make sure that you've sort of bought into the specific nuances of Cosmos that are maybe not surfaced in the Spring Data layer. And there's not many of them, so just as long as you're good with those, then yeah, you're probably good with the fact that you're not able to tune transport layer down to the nth degree.
You know what? This is true. Like, it's an ORM, but that does not mean you do not care about kind of ultimately the design underneath and the model and your partition strategy. All that stuff matters, and you better surface that regardless of what you're using to touch that data and what ORM you're using. Exactly. That is absolutely correct. You cannot abstract away the underlying storage itself fundamentally. So yep.
So last thing, I don't know how I'm doing for time here, Mark. You can tell me.
Talk all day.
Okay. Don't say that. So I wanted to touch on the Spark connector. This is been going for quite some time. It's actually, I think it's the first connector that we built on top of the Java SDK. Although back in those days, it was the architecture was different. These connectors didn't depend on the core SDK. They were separate, and of course we've changed things since then. I guess like a kind of basic view of Spark. This is really talking more about Spark than the Spark connector. I'm not going to try and describe how Spark works, but at a very high level, of course, Spark works with something called data frames, which are a kind of distributed data set that's tabular, but the data underlying is split into partitions in the Spark world, and each of those partitions has its own worker node. And then within worker nodes, you have executors, and some of that data is held in memory, some of it is on disk, and you have tasks executing these things. And of course, the great high level thing about Spark is that it can process data in memory, and when it runs out of space in memory, it spills over into disk. So it's super efficient for that, and it's one of the most, well, probably the go-to framework, software framework for doing massive scale data processing or data movement. That's really the big use case that we see. And in Cosmos DB world, the Spark connector for each of these Spark partitions will have an instance of something called bulk write in the Cosmos Spark connector that is going to have in memory buffering of data for each physical partition in Cosmos DB, and then it flushes this by sending a single request, ingesting multiple documents. So it's really kind of eking out the parallelism that's possible by default in the Spark framework. One of the trade-offs of the default behavior is if you're ingesting a very large amount into a target container that has many physical partitions, this can become suboptimal. But there are configurations that you can do, and we have some documentation if you need to get into the weeds for that purpose. So I kind of like a very sort of high level anatomy of what an ingestion or indeed a data movement script in Scala would look like. You can also write this code in Python and different languages over Spark. Scala is the native language in Spark. You'd have Cosmos credentials. You'd have some config related to Cosmos DB. You'd activate something called Cosmos Catalog in the Cosmos Spark connector, which is what you need to be able to do operations against database and container. And then you'd have your various operations. In this case, we're creating a database, we're creating a container, and then we're creating a data frame and then writing that data frame to a container. So fairly simple example. Just a zoning on the configs. So some, again, 101 things that everybody should know. Cosmos reads partitioning strategy. This means Spark partitioning, not Cosmos DB partitioning. In Spark 3, by default, we have this new capability that allows the underlying SDK to scope queries to just a fragment of the physical partition. So by default, we'll ensure that at least as many Spark partitions as executor cores are created, so we can take advantage of this massive degree of parallelism that you get in Spark. And for most cases, this would be fine. But if you're doing things like very targeted filtering to just one logical partition, for example, it's probably better to use restrictive partitioning strategies. So that just means one Spark partition per physical Cosmos partition. So that's just another little gotcha that sometimes customers get into. The other thing to point out is max item count. This overrides the maximum number of documents that can be returned for a single query or change feed request, depending on what you're doing. The default value is 1,000. You should only really consider increasing this if the average document size is much smaller than 1 kilobyte, which isn't very often, or if projection reduces the number of properties in the query significantly, etc. There is another reason why you might want to reduce this, depending on the size of the documents and so on, is if you're using throughput control. And throughput control is a feature that we introduced quite a while back now. It's pretty mature these days. And this is specifically for isolating the performance needs of an application that's running in the container from your Spark job. So it's quite common when anybody is running anything in Spark. Usually they're doing something in batch. They're moving a large amount of data from one place to another. And of course, you don't want to saturate all of the throughput that's available in that source system, whatever it is. So you can configure, as you can see here, a target throughput threshold 0.95. That means I only want to consume at maximum 95% of the throughput available in the container. Maybe 95% is a little high. Typically, what we see is more like 20% or some small percentage. And so there'll be local throttling on the throughput that's being consumed. The one gotcha, though, and this is why I mentioned max item count, is if the query that you're running happens to that single query happens to cost more in terms of RUs than the configured limit, there's nothing throughput control can do about that, because it's always reacting to the cost of the most recent query, right? It's not being this throttling isn't happening at server side. It's being constantly reevaluated at the client side. So if you want to make this more accurate or more effective, you want to reduce the item count so that it's not possible for a single request to exceed the throughput limit, and then it's always slipping through the net, as it were. Something else worth looking at here is something called priority-based execution. That is controlled at the server side, but it's based on a priority for each request, and depending on whether you have low or high. If you set the priority to low, then all those requests will be throttled first in the case of throttling that's happening at the server side. So if you want it to be more reliable in terms of regardless of what the request is, and not having to make tweaks like what I've just suggested, maybe this is worth looking at as well. And of course, you can use both of these in combination. And of course, throughput control and priority-based execution is available in the Java SDK as well. It's a very useful feature.
Not available in .NET SDK, by the way. Well, priority-based at server side, but the throughput control, and that's I've often lamented that. That is a very cool and handy feature, and one that customers really. I mean, everybody needs something like that, I guess, for using Cosmos if they're trying to ingest or move a lot of data.
Yeah, initially, I mean, it really emerged in the Spark case. That was where it was first introduced, because it's so important when you're doing big jobs, and otherwise you're forever trying to find windows where nobody's using the system and things like that, and having people shouting at you when their application's not working. So yeah. Definitely a useful feature.
By the way, Fun fact, I went and looked at the source code for that in the Java SDK. Very nice implementation, I have to say. It's
Yeah,
a very nifty piece of code that does the
yeah.
throughput control in there. So
It's so simple as well. The idea is just so, just
yeah,
so simple.
yeah.
Yeah, but I mean, it's not a simple implementation, but just conceptually how it's working.
It's correct, but it's a nifty way they implement it. I'm very much a fan. So
Yep. Yep. Yeah, and so of course the other big use case for Spark, the one being ingestion and data movement, the other is streaming, of course, and we have not surprisingly implemented an integrated change feed into the Cosmos Spark connector. So again, the anatomy of what a notebook script might look like is you're going to have a bunch of config that relates to the change feed and the target and the throughput control container. You'll have a checkpoint location. I want to call out, this is probably one of the most useful features, in my opinion, maybe one of the most underrated features in the Cosmos Spark connector, is the fact that there is built-in checkpointing for when you're streaming on the change feed. And this is one of the reasons why so many customers use the Spark connector for doing things like live container migrations, or even just not necessarily a migration, but they want to move from one container to a different container with different properties, and they do transformations in between. It's because it has checkpointing built in, right? And of course, checkpointing is something that needs interaction with the target location, right? So because Cosmos Spark Connector has all of this within its gift, it's easy for it to implement that logic all self-contained. But there isn't any other framework that we have like this, the change feed processor and so on, where checkpointing can be easily built in. So it's a very useful aspect of the Spark connector.
Yep, exactly right. Yeah, I don't know what to say. You got to build it yourself if you're going to use the .NET SDK.
Yeah. And it's not trivial, right? Checkpointing is not as trivial as it seems. So yeah, it's useful to have it there. And then of course, you're going to be calling read stream with format of change feed, and that's going to implement those features in the connector, and then write stream on that data frame to then write the data out that's being streamed into your target container there. And so that's some things to call out here. The change feeds start from like as with the change feed processor in the Java SDK and even the .NET SDK as well. You can either start from the very beginning, so you can stream everything from the beginning, which makes it useful for live migrations if you want to get all the historic data as well and be sure that you're getting all of the live updates. You can start from the current time, or you can start from a specific time. The big thing to note here is this is ignored if there are bookmarks and you've specified a checkpoint location. Checkpointing overrides any of these settings. This is another gotcha that we sometimes see. People set a checkpoint location, they run the thing once, they run it again to start again, delete all the data in the source thing, and oh, it's not working. It's because it's not because it's obviously it stopped at the last checkpoint, so there's nothing left to move over. And there's change feed mode. Of course, we have now latest version or all versions and deletes. I won't talk too much about the different change feed processor approaches. And then there's item count per trigger hint. The only important thing to note here is this is the max number of items that can be read from the change feed for each micro batch trigger. But if this is not set, then all available data in the change feed is going to be processed in the first micro batch. So it's important to have some setting for this in the config. So that's everything for Spark. And the last thing I have to talk about is, but not least, is the Kafka connector. And I'm going to start with an elephant in the room here. So if you're a power user of Cosmos DB and you use change feed a lot, you're going to think to yourself, well, change feed is used for event sourcing, and I've got a nice publish and subscribe model, and it's very distributed and it's very performant and low latency. Why on earth would I use the Kafka connector? And the answer is, yeah, in that scenario, if it's homogeneous and everything is Cosmos DB at the back end, and latency is absolutely crucial, then of course use change feed. But I would say for everything else, Kafka's feature set is really rich, especially if this is running on Confluent. I'm going to cheat a little bit here and say, hey, check out the video that Jacob did with you a while back, Mark. It was a really good video, actually. It covered a lot of different stuff, things like schema enforcement and how you can interrogate the queues in topics and so on. There's a lot of stuff available in Confluent. And one thing I would say is if you've ever tried to install Apache Kafka yourself, you'll know this is not an easy thing to do yourself. Of course, this is a SaaS offering in Confluent, and everything is drag and drop, and it's super easy. And the Cosmos DB source and target connectors are just one of the many connectors that they have. So this is a very worthwhile thing to look at. And of course, we're working in partnership with them and supporting the connectors and improving them all the time. And that's it. That's everything. I don't know how long I've been talking. It feels like 10 minutes.
10 minutes, yeah, an hour and 10 minutes actually. We're
really
at right about now, but yeah, there's, just a lot, and this is why having you on is just so important. I want to throw a couple other links up we didn't quite get to. You have done so we have our sample Cosmic Works that was started a few years ago, and I and some others have maintained that thing. And you've gone and created a Java version of this thing, which for anybody, and we kind of touched on this earlier, like SDKs are one thing, but the underlying design and model of your data and the model of your documents, and then of course how you partition this data, right? And partition is how you scale. Is super important, and you've created essentially a Java version of this thing, and I just wanted to highlight this for folks as the Cosmic Works Java repository out on GitHub, and I want people to go and take a look at that because it doesn't matter which language or which framework. You could even be talking to us using REST API, but the model and the partition strategy is absolutely critical, no matter how you're accessing your data. For performance and scale. So
yeah, it's really great if you're coming from the relational background as well, and if you're familiar with the AdventureWorks data set as well. If that's your starting point, then that Cosmos Works repo, whether it's .NET or Java, is really useful, I think. Yeah,
and that's why that was a good data set to use, because most relational folks, at least in the Microsoft ecosystem, may have learned SQL Server using AdventureWorks data. So hopefully provide them something familiar to start with. You had another link in here. I did not get a chance to show this one, but your cloud scale data for devs guide. You want to talk about that for a second?
Yeah, so this is kind of a guide. It's quite a holistic guide, so it actually talks from the top down about Cosmos DB and all of the different other sort of technologies that you can use with Cosmos DB as well, but geared towards building apps on Spring. It does use the Spring Data client library as well, but it also talks about things from the context of Spring Boot. So it's one take on it. Uses the Spring Boot starter library as well. So yeah, there's a lot of useful stuff as well. If you're completely new to Cosmos DB, but you're used to using Spring, maybe that's a good place to start, is going through that. And you're the type of person that likes to go through ebooks or tutorials and follow things through, then it's definitely a useful.
Did we produce this? Is this from the Java SDK folks, or?
This was I don't know. I think it was a partner that produced it, and then we also.
Oh yeah, right. I remember this.
Yeah,
okay.
We did some contributions to it as well.
Yep, so. Yep. Okay. Well, this is awesome. Thanks for coming on. As always, just a whole ton of innovation and stuff that the Java team has done on our team here. It really, in some ways, is our most advanced SDK or set of SDKs in the Java ecosystem there. So if you're a Java developer, you've got a very good developer experience, I would say, using Cosmos and you can build some amazing apps using us. and hope you do and check us out. So, hey, Theo, thanks so much for joining us. I'd love to see you again. And so come on back anytime.
Thanks, Mark. Been a pleasure.
Okay. Thank you, everyone. We'll see you next time.